Good morning to all. Now, this session is in continuation with the previous session. In the previous session, just we started various kinds of systems, and we started discussions. In that one, just we began with the first concept, that is called dynamic and static systems. This session is in continuation of static and dynamic systems. Let us start. In the previous session, just we made static system and dynamic system. Static system is memoryless and dynamic system is with memory. What is memoryless? Memoryless means what? Can't get previous response. Memory means what? It gets previous response also. With present response. Similarly, with the present response. Now just look at. This is the differentiation between static and dynamic. So, static and dynamic means how to look into this one. First thing what you have to know is a static is memoryless. A dynamic is memory. What is the difference between static and dynamic? The memory and memoryless. Memoryless means it is capable of responding to the present output only, but it can't get the previous response. But regarding this one, it not only gets the present response, but also able to get the previous response too. That is called dynamic system. For example, look at, in your third semester, you already studied the concept of digital logic design. In digital logic design, there are combinational circuits. Now, and also sequential circuits. Combinational circuits are what? Memory. No memory. Sequential circuits stands for what? These are with the memory. Look at. That means what? A system that supports only combination circuit, those are static. A system that supports sequential, that is called dynamic in electronics point of view. Now, the same concept just we are discussing. So, the main difference between static and dynamic is called memoryless and memory. For example, just look at, you take one mathematical response. You take one mathematical equation, y of t equal to x of t plus x of t minus 3. Now, verify. What kind of equation is this? Suppose if equation is able to be, if this equation happens to be static, what will happen? Static means what? Always responses to the present value. Present means, for example, 1 second. For example, put t equal to 1. T equal to 1 was present value, or you can make it 0 also. Choice is yours. T equal to 1 means what? Y of 1 is equal to, put wherever there is t, substitute t equal to 1, that is 1 plus x of minus 2. Now just look at this equation. Y of 1 is equal to x of 1 plus x of minus 2. Here you can make the system whether it belongs to static or dynamic. Make upon this one how this system will become static. Static means what? The system should respond to only present x equal to 1 value. X equal to minus 2 means what? After moving backward from 1, you will get 0. Again going backward, minus 1. Again going backward, minus 2. All these are previous responses. So this is present response. Minus 2 means previous response. If it is capable of only responding to the present value but not capable of responding to previous value, this system is called a static system. This system is called static system. For example, now this system is capable of the present value but also capable of responding to the previous values, then this system is called dynamic system. This is called dynamic system. Now just look at the difference between these two. So whenever in examinations also they will give you, they will check our reactive one. For example, look at x of t plus x of, for example, t minus 2, 2 minus 2. Verify whether, students have to very clearly observe, verify whether the system is static or dynamic, or analyze the system is static or dynamic. This is the question they will ask you for short answers also. It will be, or it can be for 2 marks questions or 3 marks questions as well. For example, just look at how they ask. They will ask like this. How they will ask? Now just look at. They will ask like this. A mathematical equation will be given, that is x of t plus x of t minus 2, for example. Verify or analyze whether these systems, when these systems can be static or dynamic. Now then, in this way, just you have to put t equal to 0 or t equal to 1, anything, no problem. Now just the output can be y of 0 equal to x of 0 plus x of minus 2. X of 0 is, what is this x of 0 presents for? This is the present value. Present value. In the present value, time equal to 0. Now substituting time equal to 0, you will get y of 0 equal to x of 0 plus x of minus 2. This is plus x of minus 2. Now here x of 0 represents the present response. X of minus 2 represents previous response. Now just look at, if x of 0 is okay but not responding to x of minus 2, this kind of system is called static. Second case, if x of 0 is responding, in addition to that, it is responding to x minus 2 also, both are accepting, responding. In that way, the system is called dynamic systems. So this is the mathematical description of any mathematical equation, especially with respect to static and dynamic systems. It is always followed by a mathematical equation. Always followed by a mathematical equation. So students have to refer this very carefully. This is static and dynamic. So one important point, just we are supposed to make it, is that static means always memoryless. Always memoryless. Dynamic means always memory. These two things students have to observe very clearly. This ends the topic of static and dynamic. Now next topic is Next topic is causal, non-causal systems. The second topic is called causal and non-causal. Causal and non-causal systems. Now look at causal means what? Causal means a system depends only on the present value but does not depend upon the future values. That is called causal system. So causal means a system that depends on present responses or present values, present response, but doesn't depend upon future response. Doesn't depend upon future response. That is called causal system. That is called causal. What is non-causal? Non-causal means the system depends not only on present response but also depends upon future response. That is called non-causal system. So causal system, non-causal system. For example, look at y of t equal to x of t plus x of t plus 3. Look at this one. For example, look at put t equal to 0 or t equal to 1. In this case, y of 1 is equal to x of 1 plus x of 4. Look at this. That means what? T equal to 1 means what? Present. So here x of 1 is present. Now just look at in the scale, in the any given scale, this is 0, 1, 2, 3, 4. Here minus 1, minus 2, minus 3. Minus 3. Now here present. If you move towards right direction, it will be future. All these comes under past. Now just look at it. That means what? This system depends upon future. This is future response. Future response. That means what? This is called non-causal system because it gets the present value, but it is depending on x4 means what? Future values. After 1, you have to go for second 2. After 2, 3. After 3, 4. This is future response. Therefore, it depends upon the present as well as future. Therefore, the system is called non-causal system. Non-causal system. For example, look at y of t equal to x of t plus 2 times x of 2 times x of t 2 times x of t t plus 1. 2 times x of t plus 1. Here also if you put t equal to 1, what happens? Y of 1 equal to x of 1 plus 2 times x of 2. X of 2. In that case, what happens? Again it becomes non-causal system. So now we have to give examples of causal systems also. So in this session, we are going to learn the difference between causal systems and non-causal systems as well. So the continuation will be in the next class. In the next class, we are going to discuss the examples on causal system. So one thing you have to make it, causal means the system not only depends upon the present response but also on the future. So one important point, one important thing you have to make it, the main static, dynamic, here casual, non-casual. Now just look at present plus previous concept. These two are based on present plus previous. Here the concept is based upon present plus future. Look at this is important difference between static and dynamic systems, casual and non-casual systems. In these two cases, present is common, present is common. If previous is included, you have to shift your discussion to static and dynamic. If future is included, you have to shift your discussion to casual and non-casual system. In either of the cases, present is common. The present is common means what? Present response is common. Along with present response, if previous concepts are included, definitely you have to say either it belongs to static or dynamic. Along with the present, if future concepts are included, you have to shift your discussion towards casual and non-casual system. There's a present and future. Here present plus previous responses. So students have to make the clear-cut differences between these two responses. So static and dynamic systems are different, casual, non-casual systems are different. So to make the differentiation between these two, just students have to make a table like this. This is analysis table. Present and previous, static or dynamic. Present plus future, casual or non-casual, static or dynamic, casual or non-casual. This is a clear-cut difference. In the next class, we are going to give examples on non-casual systems. Then again, just you have to make a clear-cut distinction between static and dynamic and casual and non-casual. Thank you.